And again, happy Friday. Here we go. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. Okay, so today, eventually we're going to get on to 5.6, but first I have several questions that students asked. The first one, these are all from 5.5, I believe. The first one, this is number 18. And again, your numbers may be different from this. There were two questions. The first one, part A, says quantity 12 minus 3st minus 2s squared t, and then plus the quantity 4 minus 5st. All right, so we're adding two polynomials. Since there's nothing in front of the first polynomial, we can just get rid of the grouping symbol and write 12 minus 3st minus 2s squared t. Since there is a plus sign in front of the second set of parentheses, that would be like taking plus 1 times it and distributing that, we would just get plus what's inside. So getting rid of the grouping symbols, we've got that. The 12 and the 4 are like terms. The minus 3st and the minus 5st are like terms. I think what I'm going to do, I'm going to think in terms of the variable s. So the highest power of s is in the term that says minus 2s squared t. So I'll write negative 2s squared t. And then I'll put these together. Minus 3st minus 5st is minus 8st. And then 12 plus 4 is plus 16. So we get that answer. Any questions about that? All right, part B, it has, let's see, it's the same problem except instead of adding the two polynomials, we are subtracting them. So we're still going to get the same thing in front because there's nothing in front of that first group. But now we're going to distribute the subtraction. So that's like taking negative 1 times 4. So minus 4, and then minus times minus is plus 5st. Again, combining like terms, these go together, those go together. I'm going to put that up front. Negative 2s squared t. Minus 3st plus 5st would be plus 2st, and 12 minus 4 would be plus 8. So there we have the second answer. Any questions about that? Okay, well, I don't know whether to say the most popular or the least popular problem was definitely number 21 on this assignment. Before I look at 21, well, actually, let me just remind you what it is. So we'll look at a picture of problem 21. It's this set of 3 pulleys on a fan belt. You're given the entire distance around the whole thing, and then you're given the distances for most of it, except for this one piece. You're supposed to find the missing piece. Okay, I want to look at a different example, to hopefully get a good idea of what's going on. Let's say I had this figure. Okay, and over here I'm going to have a copy of the same thing, more or less, maybe not quite as good, but let's say that I told you that this length was 6 inches, this was 7 inches, and this was 8 inches, okay? And I said, how long is x? Okay, that's my unknown. Now, here is the second one is the exact same piece, but I told you that it was, let's see here, that the entire distance all the way around it was 31 inches. Okay, so even though they don't look exactly the same because I'm a lousy artist, the first one and the second one, they're just two ways of describing the same, I believe this is a trapezoid. Okay, so we know all of the dimensions of this figure except for one. And we also know its total perimeter. So how am I going to find this piece? Well, the first thing I'm going to do is I'm going to add up the pieces that I know. So 8 plus 6 plus 7, 8 plus 6 plus 7 is what, 21 inches. Okay. But the whole thing is 31 inches. So how am I going to find that missing piece? I'm going to take the whole thing minus all of the pieces that I know except one. So the remainder is going to be 10 inches. Do you have any questions about this example? All right. Now, 21, we're going to do the exact same thing. Instead of a trapezoid, it's this figure here. Okay. So I'm going to start, tell you what, let's start. This is the unknown piece. I'm going to start here at the bottom, and I'm going to go clockwise and add up the pieces that I know. Let's see. Let me draw that picture, sort of. Yeah, it's a good thing you can't see what I just did. It looks awful. Okay. So I've got 2 pi plus x squared plus 5x, oops, plus pi plus x squared minus 3x plus 1.5 pi. Okay. Now, I also know that the whole thing is 3x squared plus 19x plus 4.5 pi inches. Now, I realize that everybody probably has different numbers, but the idea is the same. Okay, so now let's go back to my other screen. See, I told you I was a lousy artist. Here, we'll put these little circles in there. It looks like the head of my Norelco razor. So there's this unknown piece here. I've got the 2 pi plus the x squared plus 5 pi plus you know, all of that. So what does all of that add up to? Well, let's see. I've got an x squared and an x squared. That's 2x squared. A 5x minus 3x. That's 2x. 2 pi plus pi is 3 pi plus 1.5 pi is 4.5 pi. So that is the distance around this pulley system except for that one missing piece. Okay, and again, on your problems individually, you may have different numbers, but it's the same idea. This is the total distance around that pulley system. So how am I going to find the missing piece? I'm going to take the total distance minus everything but that one piece. Okay, I'm going to recopy those two numbers on the next page. So I've got, let's see, 3x squared plus 19x plus 4.5 pi, okay, minus this 2x squared plus 2x, 2x squared plus 2x, and then plus 4.5 pi. All right, so I've got the total distance minus everything but the missing piece. So I can bring down my first trinomial because there's nothing in front of it. But then I'm going to distribute the subtraction sign. So minus 2x squared minus 2x minus 4.5 pi. Combining like terms, I get x squared plus 17x plus 0. So basically just x squared plus 17x inches. So that's the answer to this particular problem. Again, your question may have given different dimensions, but I think they all had that one missing question mark piece over on the right, and that's what that looks like. Any questions on that, number 21, before we go on? All right, I'm also going to look at one other problem. Let's see here. Let's make sure I'm sharing just my regular screen there. Okay, so give me just a minute here. I need 27.5. Yeah, 5.5. We're going to look at number 20 on this particular assignment. Okay. All right. Here again, I think everybody had the same picture for problem 20, but perhaps you had different polynomials describing the distances. So the first thing is the length is made up of a of x feet plus b of x feet. Well, if we look up here, a of x is x squared minus x plus 5, and b of x is 4x plus 6. So, oops, we've got, let's see, x squared minus x plus 5 and 4x plus 6. Okay, I'm going to switch back to the other screen for a second, maybe. So these two polynomials represent a of x and b of x, okay? Now, let's go back and let's look at the other side. Let's see, this was called the length. And then over here, we've got the width. Let's see. And we've got c of x plus d of x. C of x is x squared minus 6x plus 3. X squared minus 6x plus 3. And d of x is 3x plus 1. Okay, so what I've got on my pathetic looking drawing is I've filled in the actual polynomial. So the length is this plus this, the width is that plus that, okay? Any questions about where I got all those numbers? All right, let's go back again and see what the questions are. The first question says, what is the difference in the length and the width of the one-bedroom apartment shown above? So we're going to take the total length minus the total width. All right. Well, let's see. The length is x squared minus x plus 5. So that plus the 4x plus 6. So we get x squared minus x plus 5 plus 4x plus 6, which is x squared plus 3x plus 11. Okay. And that's what, feet. So that's the total length. Any questions on that? All right. So let's get the total width. We're going to add those and we're going to get x squared minus 6x plus 3 plus 3x plus 1, which is x squared minus 3x plus 4 feet. So there's the total width. Okay. So now to get the length minus the width, we're going to have x squared plus 3x plus 11 minus the quantity x squared minus 3x plus 4. Still with me? So now I've got x squared plus 3x plus 11 minus x squared, minus a negative is plus 3x minus 4. Combining like terms, the x squareds cancel out and I get 6x plus 7 feet. Okay, so that's the difference in the length versus the width. The second question says, find the perimeter. Well, the formula for the perimeter of a rectangle is 2 times the length plus 2 times the width. Well, I know the length, it's right here, and I know the width, it's right there. So the perimeter equals 2 times the length, which is x squared plus 3x plus 11, x squared plus 3x plus 11, plus 2 times the width, which is x squared minus 3x plus 4, x squared minus 3x plus 4. All right there? So now I'm going to distribute the 2, and I get 2x squared plus 6x plus 22, plus, again distributing that 2x squared minus 6x plus 8. Combining like terms, I get 4x squared. Those cancel. Let's see, 22 plus 8 plus 30. Oops. Inches. So the perimeter, 4x squared plus 30 inches. Okay, let's see here. I did that. And as I say, I had actually 3 different people ask for number 21, but hopefully you'll see the process is the same. Any questions other than 18, 20, or 21 that you'd like to look at before we go on to the next section? All right, so we'll go on to section 5.6, and let me close that up and make sure I'm sharing the right thing. So we're back to my whiteboard. All right. So a couple of days ago, we looked at polynomials, monomials, binomials, trinomials. We talked about the coefficients and the powers and the degree of each term, the degree of the entire polynomial. Then yesterday we added and subtracted polynomials. So today we're going to be multiplying polynomials, and eventually a few days we'll be dividing polynomials. So let's take a look at examples of multiplying polynomials. Let's say we have a monomial, negative 2a cubed, times another monomial, 11a squared. All right, now the quick, easy answer is negative 22a to the 5th. But let's go back and break it down and see how we get that. First of all, this is like having negative 2 times a cubed times 11 times a squared. Multiplication is commutative. We can switch the order in which we multiply factors. So I could take those two and switch them around, and then I'd have that. Now, why would I want to do that? Because that puts the coefficients together and the powers of a together. Negative 2 times 11 is negative 22. But what about a cubed times a squared? Well, there's a rule that's back that you would have learned if you took Math 85, which some of you did and some of you just tested in here. It's in section 5.2, the first half of this chapter, that says when you're multiplying 2 powers that have the same base, you add the exponents. So a cubed times a squared would be a to the 3 plus 2 power, or a to the fifth power. So that's how I get from here to here. But again, you don't have to write all these steps, but just to understand what goes on. So you can just say, oh, this times this is negative 22, and that times that, a to the fifth power. And we can't put that together any further than that. All right. Do you have any questions about this rule or anything I did there before we go on? Okay, we're going to look at another example of that same kind of idea. 3y times 7y squared times negative y to the fourth. So I've got 3 times 7 times a negative 1 would be negative 21. Okay. I've got y times y squared times y to the fourth. So that would be y to the, there's an implied 1 on that y. 1 plus 2 is 3 plus 4 is 7. So negative 21 y to the 7th power. Any questions there? Tell you what, I'll quit asking you if there's any questions. If you have any questions, just interrupt me, okay? And of course, no one answered that either. All right. You've all gone off to take a nap somewhere and you're not even there, right? You're pretending.
Sorry, I just woke up.
Oh, okay. All right.
I'm here too. I'm just tired.
I'm here, I swear.
Sure you are. Okay. All right. There's still people that think, well, attendance is mandatory, so I'm just going to click on here and then I'm going to go off and go back to bed, but no one will know until I say, is there anyone here? Yeah. Okay, moving on. Let's see. We've got this one, which is, I just get lonely here. Negative 2/3 x to the 6th, feeling like I'm just talking to myself. I probably do that more than I realize. All right. Now, I want to pull this one apart again just to show you what's going on there. So I could rewrite this as negative 2/3 times 9 times x to the 6th times x cubed, right? So in other words, I could put this and this next to each other. They're being multiplied. But negative 2/3 times 9 is like negative 2/3 times 9 over 1. I could reduce that down to 3 over 1 and make that whole thing into negative 6. We okay there? All right, so basically what I'm saying is, from here I could go, that becomes 3 over 1. Negative 2 times 3 is negative 6, and then I've got x to the what? 6 plus 3 is 9. All right with that?
Yes.
Okay. Are you sure?
Yeah, I'm bad at fractions. It's fine.
Fractions are your friend. Fractions are your friend.
Hey, I'm just writing this all down so I can look at it later.
I see. You could always just look at the movie. I mean, get some popcorn and look at the, whatever. All right. Next problem. Now, let's say I've got a times a plus 2. So I'm going to distribute the a outside, and I'm going to have a times a, which is a squared, plus a times 2, which is 2a. I can't put a squared and 2a together, even though they contain the same variable. They're different powers of the variable, so they're not like terms. We can't put them together. Let's say I have 3a times a plus 2. So now I'm going to distribute the 3a. I'm going to get 3a squared plus 6a. And again, there's my final answer. All right. Let's say I've got negative 4b cubed times 2b squared minus 2b plus 2. So distributing, I'm going to take negative 4 times 2, which is negative 8, b cubed times b squared, which is b to the 5th. Then I'm going to take negative 4b cubed times minus 2b. Negative times negative is positive. 4 times 2 is 8. B cubed times b to the first power is b to the fourth power. Then I'm going to take negative 4b cubed times positive 2, which is minus 8b cubed. And there is our final Jeopardy answer, and it's in descending powers of b.
Okay.
All righty.
Yeah.
Now we're going to head out into the deep end. So get your life jackets on. Let's say we've got a times a plus 5. And then we've got 4 times a plus 5. Okay. In fact, I'm going to put a plus sign here and make this into one big problem. So I've got a times a plus 5, which would be a squared plus 5a, right?
Yeah.
And over here, I've got 4a plus 20, but we're going to bring that plus sign down. So now we're going to add all of it up, and we're going to get a squared plus 9a plus 20. Okay?
Okay.
So I took a times a plus 5, and I took 4 times a plus 5, and I got that. Now, let's take a plus 4 times a plus 5. I'm going to do the exact same thing. I'm going to take this first a times the a plus 5. So a times a is a squared. A times 5 is 5a. Now that I've exhausted all the combinations of multiplying this a times the a plus 5, I'm going to move on and do the 4 and get 4a plus 20. Finally, combining like terms, I'm going to get a squared plus 9a plus 20 as my final answer. So what we've just done is we've multiplied together 2 binomials.
Okay. Got it.
I'm going to do the exact same problem again. It helps if I write it down. Let's see, a plus 4 times a plus 5. A plus 4 times a plus 5. This is sometimes referred to as FOIL, and this stands for first.
First, outside, inside, left.
Yeah, outer, inner, outside, inside, sure. And last. All right. We're going to take
Whoa.
first. Sorry, what? Question? No? Okay. We're going to take the first times the first, and we're going to get a squared. Then we're going to take the outer times the outer, which is going to be the plus 5a. Then the inner times the inner, which is the 4a. And then the last times the last, which is the plus 20. And then combining like terms.
Oh, the heck.
What?
You
Whoa.
froze for whoa.
You just time jumped.
Yeah, that was crazy.
What
Yeah,
happened?
you froze and the
froze
whole
for a
screen
long
just like
time.
filled instantly.
Yeah.
Yesterday afternoon during my office hour, we're having a terrible time.
Yeah.
It took me like, yeah, you were there.
Yeah, it was. It was like every 5 seconds it would drop the call for some reason.
Yeah. Maybe I should pay my internet bill. I don't know. I kept, whatever. It's weird because I didn't see anything strange here, but then things are always strange here. So what do I know? All right. Anyway, are we all back? Am I unfrozen?
Yes.
Yes, you're unfrozen. We're all good.
Okay. I'd be careful. Disney will sue me for slander of their songs. All right. Anyway, this is the big deal today, right there. The idea of multiplying polynomials together. So let's look at 12,000 more examples, okay? Well, or maybe at least 12. Here we go. So I've got m plus 6 times m minus 9. So I'm going to take m times m, which is m squared, m times a minus 9, which is minus 9 m, 6 times m, which is 6m, and 6 times minus 9, which is minus, 54. Then, combining like terms, I get m squared minus 3m minus 54. Any questions there?
Nope.
All right. We good to go on?
Yeah.
I have 5x minus 3 times 2x minus 3. So that gives me 10x squared. 5 times 2 is 10. X times x is x squared. 5x times minus 3 is minus 15x. Minus 3 times 2x is minus 6x. And minus 3 times minus 3 is plus 9. Combining like terms, I get 10x squared minus 21x plus 9. So there's your final answer. Okay. Now let's turn up the heat a little bit. 8t minus 1/2 times 4t minus 5/2. Everything is fun and games until you introduce fractions, right? And it's just no fun anymore. You know, I have a theological statement to make that no one has ever argued with me about. Okay, so where was the first fraction introduced? Well, it was in the garden with Adam and Eve. You know, when they took a bite out of the apple, there was now a fraction and sin was introduced to the world. And no one has ever disagreed with me that sin and fractions seem to be the same thing. So there you go. All right, moving on.
I'm going to use that.
Of course you are. Of course you are. All right. No one will argue with it. Here we go. So we're going to take 8t times 4t, which is 32t squared. Okay. Then we're going to take 8t times minus 5/2. Well, I'm going to write this. I'm going to write plus 8t times negative 5/2. I'm going to come back later and clean that up. Okay. Then I'm going to take minus 1/2 times 4t. And then I'm going to take minus 1/2 times negative 5/2. So I put the first product together because it was easy to see. The other ones, I left them so that we could kind of walk through them together. Okay. So I've got 32t squared. But now this 8 is in the numerator and this 2 is in the denominator. So I could make that into a 4 over a 1. So I've got plus 4t times negative 5, which would be minus 20t. Now, I could have gone straight there and skipped this step, but I suspect if I had, people would have been like, what happened? What happened? Where did you go? So, okay. Here, we've got minus 1/2 times 4t. The 4 over the 2 is 2 over 1. So I've got minus 1 times 2t, or minus 2t. And then finally here, minus times minus is plus 5/4, multiplying straight across. Combining like terms, I've got 32t squared minus 22t plus 5/4. So there's my final answer. All righty. We're going to expand our horizons. Now, instead of multiplying a binomial times a binomial, we're going to multiply a binomial times a trinomial. X plus 2 times x squared minus 2x plus 3. So now it's sort of an extension of FOIL because I'm not going to have 4 products. I'm actually going to have 6 of them. So I'm going to take the first times the first, which is x cubed, the first times the next one, which is minus 2x squared, and the first times the last one, which is plus 3x. Once I've exhausted all the combinations of that first factor, or the first term in the first factor times everything in the second factor, I'm going to move on to the next one, plus 2x squared minus 4x plus 6. Combining like terms, and at the same time, I'm going to put them in descending powers of x. So I'm going to start with x cubed. Oh, those are going to cancel out, so I don't have any x squared. 3x minus 4x is minus 1x, and then plus 6. Oh, I need to mention something. This came up yesterday with a student. For whatever reason, in WebAssign, it doesn't like it if you put the implied 1 as a coefficient. So for instance, if you wrote this answer like that, I believe it's going to reject it. And you're going to be sitting there going, what have I done wrong? Well, this isn't wrong. It's just that the 1 isn't necessary. And so it's not expecting it. So it says wrong. Okay. So anyway, just.
No worries.
What's that?
No, nothing.
Oh, okay. Sorry, I was eavesdropping. Didn't mean
No,
to.
it's okay.
Okay. Okay. I'll turn my hearing aid off. All right. Now, this is going to seem a little bit odd, perhaps, but it actually, well, let's do this. Let's take 687 times 13. Okay. So what do? You take 3 times 7 is 21 and you carry the 2. 3 times 8 is 24 plus 2 and you get 26 and you carry the 2. 3 times 6 is 18 plus 2 is 20. And then you bring down a 0 and you've got 1 times 7, 1 times 8, 1 times 6, and you add them all up. And I know I went through that quickly, but that's how you multiply, big numbers times big numbers, right? Okay. So let's say we've got this situation. We've got x squared minus 2x plus 1 times x plus 2. Now, it might be a little confusing if I put an x multiplication sign out here. I'm going to write that in red just to show that that's not a variable. That's just meaning we're going to multiply. Okay. So what is 1 times 2? That's 2. What is 2 times negative 2x? That's negative 4x. Oh, but there's a plus sign in front of the 2, isn't there? And then this is what? 2 times x squared, so 2x squared. I suppose I could bring a 0 down here, and then I'm going to take 1 times x, which is x. Oh, I guess it's going to be plus 0. And then minus 2x times x would be minus 2x squared. And then x squared times x is x cubed. And then we add them up. 2 minus 3x. Oh, but I've got to put a plus sign. These cancel, and I've got x cubed. Now, that seems a little bit awkward. Most people, myself included, prefer this whole idea of multiplying them horizontally. However, it can be done in this vertical fashion, and that's what it would look like. All right. Now, let's say we've got 2 times 3 times 12. What are you going to do first?
2 and 3, right?
So you'd multiply together the first 2 factors, right? 2 times 3 is 6, and then 6 times 12 is 72, right? So you don't multiply all 3 of them together at once. You just multiply 2 at a time, right?
Yeah.
How many things do you think Einstein can multiply together at once?
Everything.
None. He's dead. Come on, guys. All right. Now, we've got 4x, 2x plus 1. Everybody's sitting there going, I can't believe he said that. Oh, you don't even know. I've only scraped the surface to what awful jokes or whatever I can make. So now we've got 3 things we're multiplying together: the 4x, the 2x plus 1, and the x minus 2. We're only going to do 2 at a time. We're not going to take the 4x times the 2x and then times the 1 and then times the 2x and then times the minus 2. We're just going to do these 2 things first, okay? So this is going to give me 8x squared plus 4x. Then I'm going to take that and multiply that resulting 8x squared plus 4x times the next factor, okay? So now we get 8x cubed minus 16x squared plus 4x squared minus 8x. Combining like terms, 8x cubed minus 12x squared minus 8x. All right. Let's see here. How are we doing? We're just about out of time. Okay. We good to go on?
Yeah.
All right. We're going to take a binomial times a binomial times a binomial. But here again, we're only going to multiply 2 of them together at a time. So I'm going to do these first 2 binomials. I'm going to FOIL them. So x squared minus 2x plus 6x minus 12. But I'm going to continue to simplify that further and combine like terms, x squared plus 4x minus 12 times x minus 4. So I took the first 2 binomials and FOILed them together to get x squared plus 4x minus 12. Now I'm going to take that times the x minus 4. X squared times x is x cubed. X squared times minus 4 is minus 4x squared. 4x times x is plus 4x squared. 4x times minus 4 is minus 16x. And then minus 12 times x, minus 12x. And minus 12 times minus 4 is positive 48, plus 48. Now I will do the addition and subtraction. Let's see, x cubed. These are going to cancel. Minus 28x plus 48. And there is my final answer. Any questions there? Okay, let's see.
Is it just minus 28x or is it minus 28x squared?
If I'm not mistaken, it's just minus 28x
Okay.
because you're not multiplying, right?
Ah, okay.
Right,
Yeah.
and let's take that idea and look at it a little further, because I understand how that gets confusing. Let's take this. Let's see, is it plus or minus? Compared to that. But like you said, the operation means everything. So here we're subtracting. So this is going to be negative 28x. We've got minus 16 of something, minus 12 more of something. We've got minus 28 of something. Here, when we're multiplying, let's see. Negative times negative is positive. 16 times 12 is 160 and 32, 192x squared, because here we're multiplying.
Okay.
Yeah, so or break it down a little simpler. X plus X is 2X. X times X is X squared. And
Oh,
it's
okay.
not the same thing. That's all
Yeah.
right. Keep asking, because those are things that people kind of, maybe they're confused and they don't say anything, and then it pops up in the middle of the test and it's panic time. Don't wait till then to ask questions. All right. How are we doing? Let's do this one.
Before you move on, I had a question on number 21 on 5.5. I don't know. I figured, I guess you thought you'd cover 5.5 in this lesson. I barely joined like at 11, so I.
Okay, yes, it's in the video. I went through it. You would actually be the fourth person that asked for that question. So when we're all done, go back and look at the YouTube video when I get it posted. I went through that extensively, okay?
Okay, thank you.
And then if after looking at that, you still have questions, either come back at 1:15 or email me and I'll track you down, okay? But yeah, I did go through that earlier. Sorry you missed us.
Okay, yeah, sorry
missed
about
you
that.
too.
Thank you.
I knew there was an empty spot in my heart. I missed you too, but thanks for joining us. Yeah, Mr. Mayo, just get on with things, will you? Okay, sorry. All right. It must be Friday. I must, a 3-day weekend. I'm just sort of feeling, I don't know, less stress. So how about this? We've got m plus n times m plus n. So multiplying that together, you get m squared plus mn plus mn plus n squared. These are like terms, so we get m squared plus 2mn plus n squared. And that's it. Okay? So, a reminder, Monday, there's no class, there's no Zoom sessions, there's no office hours, there's no Mr. Mayo calling you at all times of the day saying, here, let me help you with this. Basically, I'm going to be taking Monday off, you take Monday off. That means this assignment, don't wait till Monday night to do it, okay? All right, anyway, you guys have a good weekend. I'm going to stop the recording.